Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. This is your first midterm exam and which was held on 19 February 2025. So today we will solve these problems and let's see. So the first question was, which number is equivalent to 2000 micrometer? So we have to convert this micrometer into millimeter, into nanometer, or into decimeter. So this is your decimeter. But you can observe from this number, this is micrometer. Okay. So decimeter, I think it is not possible. And what you have to do? So first you should take this value. The value is 2000 micrometer. So micro mean 10 raised to power minus 6 meter. Now you can rearrange this number 2 into 10 raised to power 3 into 10 raised to power minus 6 meter. So you can add the powers of 10 raised to power 10, 3 minus 6 meter. And this is 10 raised to power minus 3 meter. So 10 raised to power minus 3 is milli because this is prefix. So you can write 2 millimeter. So it means our answer is 2 millimeter. So the answer is D here in this question. Now see the next question. In the next question is, the graph in the figure shows the velocity of a particle as it travels along the x-axis. The magnitude of the acceleration of the particle between 1.0 second and t is equal to 4.0 second is what? So you just find the average acceleration. So you know that the average acceleration is like delta v over delta t. Okay. This is your acceleration, and delta V is Vf minus Vi over Tf minus Ti. Now you can see from the graph is given, and this value is 3 because it is between 2 and 4. And this value is minus 2. And here the 1 is, time is 1 second, and this is 1, and this is 4 second. So it means this is your Ti and this is your Tf. And this is your Vf, and Vf mean this is your Vf value, and Vf value is 3, and Vi value is, because this is Ti, and at Ti the Vi value is minus 2. So Vi value is minus 2. Now how to solve this one? Now you can see that A is equal to Vf is equal to 3 minus this minus, and then minus 2 divided by Tf, 4 minus 1. So this is 5, 3 minus of minus 2 plus 5 divided by 3, and this is equal to 1.66. So your answer will be 1.66. So the answer is here 1.66, and here the answer was 2 millimeter. Okay, after this, now you can see the third question. The figure shows the position of an object moving along a straight line as a function of time. Assume two significant figures in each number. Which of the following statements about this project is true over the interval? So we have to decide either the velocity is increasing, decreasing, constant, like this one. Now in this question, you can see that the dot's position is decreasing. So it means the V is decreasing. So if the V is decreasing, the acceleration is negative. So negative acceleration means if the velocity direction is this side and it is decreasing, and A acceleration will be negative and it is in the opposite direction. So it means the direction of the acceleration is to the left. So it means this answer is the object is accelerating to the left. That's why. In question number 4, this is the question about the average speed you can see. So you drive 6 kilometer at 50 kilometer per hour and then another 6 kilometer at 90 kilometer per hour. Your average speed over the 12 kilometer drive in kilometer per hour will be what? So here you can see the 6 kilometer and 6 kilometer, the distance is same. So if the distance is same, you can directly apply the formula, and that formula is, this is question number 4. So in question number 4, you will apply V average is equal to 2V1 V2 over V1 plus V2. So direct apply this formula, 2 into 50 into 90 divided by 50 plus 90 and solve this one. So when you solve this one, its answer will be, I check this one, this is 2 into 50 into 90 divided by 50 plus 90. This is 9,000 divided by 140. 140. And this is equal to 64.28. So this is the answer. So in this way, you can solve this value is 64. Now check the question number 5. So in question number 5, this is very easy and simple question. The horizontal and vertical component of A with a magnitude of 5 are what? So A value is 5. This is A magnitude. So you drop a perpendicular, and this is this component and this is this component. Or you can make the component in this direction. Okay. But this is the easiest way. So if this angle is 60, then surely this angle will be 30. Now you can solve it easily. So how to solve this one? So this component is A cos of 30 and this is A sine of 30. So A cos of 30 mean 5 into cos of 30 and A sine of 30 mean 5 sine of 30 is 1 by 2. So this is 2.5 and surely when you solve this one, it is 5 into 0.866. It is 4 point something. Something mean 4.33. So the answer is 4.33 horizontal component and the vertical component is 2.5. So here you can see the answer is E. Answer is also this one, same. But this is here showing horizontal component, but horizontal component is not 2.5, it is 4.33. So that's why this is misconception in this these two options. Okay, so you should select this one. Okay, question number 6. In question number 6, a ball rolls up the ramp, then back down, which is the correct velocity. So when the ball is moving up, its velocity is decreasing and becomes zero, surely at the highest point. Okay. So at this point, its velocity is zero, is decreasing. So velocity is decreasing and then it comes back, its velocity is increasing, but in the negative direction because this is negative x-axis, this is positive x-axis. So in positive x-axis, its velocity is decreasing and becomes zero. So here in this graph, the first graph you can see it's decreasing and becomes zero here. This is at the highest point, okay? Highest point mean highest height here. So then it is come back and it is increasing. So this is the increasing in the negative side, okay? So our answer will be this one. Now question number 7. In question number 7, the final velocity of a cart rolling down a ramp depends on. So you can see that if any body is going down, rolling down from a ramp, ramp means that this inclined plane, it makes an angle theta. So this is the height, okay? This is height and this is length. So here you can see, so you should remember in the next chapters that velocity always depends on what? When the ball is falling down, we can find the velocity. V is equal to 2g h under root, like this one. So here h is actually what? So h is h over L. H over L is equal to sine theta. So h is equal to L sine of theta. Now you can put this value in this equation, then V is equal to 2g L sine of theta. So in this equation, you can see it totally depends on the length and the angle theta. So the answer is both the angle of the ramp and the length of the ramp. So this is the answer. Okay, in question number 8, this question is about the resultant. Vector A has a magnitude of 5. So vector A magnitude means this one, 5. B vector magnitude is equal to 15. Then the magnitude of the resultant vector R is equal to A plus B is what? So you can see that if we find A minus B and A plus B, the answer will be what? So if I find A minus B, then it is 10. And if we find A plus B, it is 20. So its range will be between R magnitude will be 10 and 20. So that's why the answer is this one. Okay, question number 9. So in question number 9, a man is pulling a box on a rough ground. What are the forces acting on the box? So it is a rough ground. Surely the frictional force will act. So this is very simple and easy. And here is the frictional force. Here is the tension force. And here is the weight. And here is the normal. So I think this answer is correct. Very simple. Question number 10. According to Newton's second law of motion, you know that second law is F is equal to ma. So here he is asking the acceleration of each object is dash its mass. So surely from here, A is equal to F over m, and A is inversely proportional to mass. So here you can select this one, inversely proportional. It's easy. Now the question number 11. A 60 kg student in a 1500 kg elevator at rest. As the elevator begins to move, he has an apparent weight of 772 Newton for the first 2 seconds. What is the elevator acceleration during the 2 seconds? So to solve this problem, first we have to decide that the elevator is moving up or down. So you know that this is question number 11. So if the elevator is moving up, then we know the formula, the apparent weight is equal to mg plus ma. If the elevator is moving down, then n is equal to mg minus ma. So these are the conditions. So we have to decide that this apparent weight 772 is, this is actually the n value, 772. So this value is greater than at rest value or it is less than at rest value. So what we have to do, if the elevator is at rest, you know that if it is at rest, then n is equal to mg. So first find this one. So m is equal to 70 into 9.8. So if we multiply this one, then answer will be 70 multiplied by 9.8. So answer is 686 Newton. So at rest, it is 686 Newton. But when it is moving, it's 772. So it means the elevator is moving up. So here we have to decide this one first. Then we will use the formula. So surely we will use this formula mg plus ma. Because if the elevator is moving up, its weight is increased. So 772 is equal to m common. 9.8 plus A. So M value is 70. This is given 9.8 plus A and 772. So 9.8 plus A is equal to, so 772 2 divided by 70. So answer is 11.02, like this one. So A will be what? So A will be 11.02 minus 9.8. So minus 9.8. So the answer is 1.22. So in this case, in this way, you can solve this one. Here you can see the answer is given 0, 18.3 minus 1.2. No, it is moving up. So 1.23. So this is the answer. Now question number 12. So in question number 12, three identical blocks, each one is hanged vertically from a cable. The first was stationary. It is stationary. The second was pulled upward at a constant speed of 5 meters per second, and the third was pulled upward at a constant speed of 10 meters per second. The relationship between the tension in the three cable is what? So because the first block is stationary. Stationary mean at rest. At rest mean its acceleration is 0. Okay. Second, constant speed of 5 meters. Acceleration is again 0. So the net force is 0. And the third was pulled upward at a constant speed of 10 meters per second. It is also constant and acceleration is 0. So it means in the whole system, the tensions will be equal. So that's why the answer is this one. Question number 13. So in question number 13 is what? Here you have to make the components first. A box is pushed with a force F on a horizontal frictionless. No friction is acting. The box acceleration is 5 meters per second. So here actually the acceleration is 5 meters per second square. Okay. So first what you have to do, again, you have to draw the diagram like this one. And this is the force and this angle is 60 degree. This angle is 60 degree. This is the F and make the components, this direction and this direction. So F cos of 60 this component and F sine of 60 is this component. So weight is acting vertically and N is this side. Okay. Now you have to find the force. So because the force is acting at some angle, we cannot find it directly. So we will find it by this component. So how we can find? So F cos of 60 is equal to the net force. So net force is MA. So find the F value. F is equal to MA divided by cos of 60. So M is given. It is 15 kg and 5 is the acceleration. Acceleration is 5. So divided by cos of 60. Cos of 60 is 0.5 or 1 over 2. Now you can solve it. F is equal to, this is 75 divided by 0.5. So 75 divided by 0.5, the answer is 150 Newton. So in this way, you can solve this problem. This is problem number 13. Now you can see the question number, this problem number 14. So in 14, the question is, a 30 kg kid slides along a horizontal floor with an initial speed of 1.6 meter per second. So the mass is given. Here I'm writing the data. Mass is 30 kg with an initial speed Vi is equal to 1.6 meter per second. This is given. The question is, if the frictional force between the kid and the floor is 15 Newton, frictional force, because it is moving, so that's why it is kinetic friction, and its value is 15 Newton. How far? So how far mean you have to find the distance x. The kids, does the kid slide before coming to rest? So before coming to rest mean before coming to rest. it means the VF is equal to 0. So this is the data, and we will apply the simple equation VF square minus VI square is equal to 2AX. So VF square means 0 square minus 1.6 square is equal to 2 into A. So A we have to find, and X we want to find. So to find A, we will use another formula. So another formula is f of k is equal to MA, because f of k is given, but sometimes mu k is given. Then we will use according to that formula. So here 15 is equal to 30 mass into A. So A is equal to 15 over 30. Now you can solve this one. This is 1 by 2. Okay. Now put this value here, minus 1.6 square is equal to 2 into 1 by 2 into x. Now here you can see that if we solve it like this one, it is minus value. But this acceleration is actually negative due to the frictional force. So this is minus, this minus and minus will become plus. So x answer you can find 1.6 square. And this x value will be 1.6 square, and this is equal to 2.56, like this one. So you can see the answer here is 2.56, this one. So this is your answer. Okay. Now question number 15 and the last question. So in last question, a box is placed on an inclined surface and the inclined angle can be increased from 0 to 90. So inclined angle mean this angle is increasing from 0 to 90, like this one. If the coefficient of the static friction between the box and the surface is 0.7, what is the maximum angle after which the box starts moving? So last time in the class, I have explained that you should apply the formula if only this data is given, and this is a coefficient of static friction, and you have to find the maximum angle, then you should apply the formula that 0.7 is equal to tan of theta. Okay. So find theta is equal to tan inverse 0.7. Now see, inverse tan 0.7. So this is around 34.99. It means this is 35 degree. So in this way, you can solve this problem. So I think this is the solution of this exam, and I hope you understand. And for your next midterm 2 and for the final, your concept should be clear. Okay. Thank you. Assalamu alaikum.